Hello everyone. In this video we are going to solve first 5 questions from QA section of CAT 2008. So I suggest everyone, once I display the question, pause the video and solve that question by yourself and then continue with the video. So let's start with the first question. So let's start with question number 1. The integers 1, 2, 3 and so on till 40 are written on a blackboard. The following operation is repeated 39 times. In each repetition, two numbers a and b currently on a blackboard are erased and a new number a plus b minus 1 is written. So what will be the number left on the board at the end of 39th operation? So let's have a look at it. So over here, out of these 40 numbers, we are going to remove two numbers, means 38 numbers are remaining, and one new number is added, means 38 plus 1, total number of terms becomes 39. So let's have a look at it. Initially the numbers are 1, 2, 3 so on till 40. These are total 40 numbers. Now after operation 1, we are going to remove two numbers and we are going to add one new number. So 40 minus 2 plus 1, that is equal to 39 numbers are going to be there. After operation 2, likewise in each operation the number of terms will decrease by 1. So now the number of terms are going to be 38 numbers and so on, and you can see that after operation 39 the number of terms remaining will be only one number. So over here we are removing a and b and we are replacing that with a plus b minus 1. Means this, in every operation the sum will decrease by minus 1. So initially the sum of these 40 numbers is 40 into 41 divided by 2, that is equal to 820. In each operation sum of all terms will decrease by 1. So after operation 1 this sum 820 will become 819. After operation 2 this sum 819 will become 818. And so on. And after operation 39 the sum will become 820 minus 39 and the subtraction is equal to 781. So the number left on the board at the end of 39th operation is 781. This is how we can solve this question number 1. Now let's have a look at question number 2. Consider a right circular cone of base radius 4 cm and height 10 cm. A cylinder is to be placed inside the cone with one of the flat surfaces resting on the base of cone. Find the largest possible total surface area of the cylinder in centimeter square. So let's have a look at the diagram. So over here there is a right circular cone and a cylinder over there. So let's have a look at it. For the right circular cone the base radius is 4. Let's name this. This is A, B, C and D, E. Let's call this point as F and this point as G. So from this we come to know that the length of GE is equal to 4 and the length of AG is equal to 10. So if I assume the length of FG is equal to H, then the length of AF becomes 10 minus H. And this angle is 90 degree. Similarly, this angle is 90 degree. So over here what we can conclude is triangle AFC. It's similar with triangle AGE. So which two triangles I am talking about? Let's have a look at it. This is triangle AFC and this is triangle AGE. The length of G is 4, length of FC, let's take it as R. This is the radius of cylinder. After that length of FG is equal to H, so length of AF becomes 10 minus H. So these two triangles are similar by using double A test. One angle is 90 degree each and this angle is a common angle. So over here what we can conclude is length of AF divided by length of EG is equal to length of FC divided by length of GE. So if we solve this further, what we will get, 10 minus H is equal to divided by 10 is equal to length of FC is small r divided by length of GE is 4. So let's solve this further. This will be 2 5s are 2 2s are. If you cross multiply, we will get 5 times r is equal to 20 minus 2h. So the value of h becomes how much? The value of h becomes 20 minus 5r divided by 2. We need to find the largest possible total surface area of a cylinder. So the formula is total surface area for the cylinder. The formula is 2 pi RH is a curved surface area plus 2 pi r square. So let's take 2 pi r common. In a bracket, h plus r is remaining. 2 into pi is a constant. Over here, let's replace the value of h. So that is equal to 2 pi r into h is nothing but 20 minus 5r divided by 2 plus r. So now this calculation becomes what? Let's have a look at it. 2 pi r in a bracket, this is going to be 20 minus 5r plus 2r is minus 3r divided by 2. So now this 2 and 2 gets cancelled out. Pi is a constant. Let's multiply this bracket with r. It is going to be minus 3r square plus 20r. Now we need to find the maximum value of total surface area. So how to find the maximum value of a quadratic expression? Over here the coefficient of r square is negative. So the formula to find maximum value is 4ac minus b square divided by 4a. So let's put the values over here. 4 into the value of a is minus 3, value of c is 0, minus b square is 400 divided by 4 into the value of a is minus 3. So if we solve this further, this will become how much? Minus 400 divided by 4 into minus 3, minus minus will become plus. So this is equal to 100 divided by 3. So the total surface area, the maximum value of total surface area becomes how much? Pi into 100 divided by 3. That is option A. After this, let's have a look at question number 3. In question number 3, one series is given. We need to find the value of this series. Let's have a look at it, everyone. So the first term is under root 1 plus 1 by 1 square plus 1 by 2 square. So this is nothing but under root 1 plus 1 by 1 plus 1 by 4. This addition is going to be how much? The LCM is 4 over here. And the numerator is going to be 4 plus 1, that is equal to 9. This value is going to be 3 divided by 2. After this, the second term is under root 1 plus 1 upon 2 square plus 1 upon 3 square. This value is going to be how much? 1 plus 1 by 4 plus 1 by 9. Over here the LCM is 36. In the numerator it is going to be 36 plus 9, 45 plus 4 is 49. This is equal to 7 divided by 6. Okay. Now what is the pattern over here? To identify that, let's calculate third term as well. The third term is going to be 1 plus 1 divided by 3 square plus 1 divided by 4 square. Now this addition is going to be how much? Under root, this is equal to 1 plus 1 by 9 plus 1 by 16. Over here the LCM is 144, so the numerator will become 144 plus 16, 160 plus 9, 169. So this is equal to what? This is equal to 13 divided by 12. So now what is the pattern over here? The numerator is 1 more than denominator. After that, in each you can see that numerator is 1 more than the denominator. And what is denominator? It is 2, 6 and 12. How 2, 6 and 12 are related with each other? 2 is 1 into 2. 6 is 2 into 3. 12 is 3 into 4. So this is the pattern over here. So let's generalize nth term. What is the formula to get the nth term over here? The formula of nth term is, in the denominator it is n into n plus 1. In the numerator it is n into n plus 1 bracket close and plus 1. So let's solve this. Let's simplify the formula to get nth term. Let's have a look at it. So if you separate the denominator, it will become 1 plus 1 divided by n into n plus 1. That is equal to, you can again write it as 1 plus 1 by n minus 1 upon n plus 1. This is the formula to find nth term. So let's have a look at it. This is the addition of how many terms, everyone? This is the addition of total 2007 terms are there. Okay, so we need to put n is equal to 1, 2, 3, so on to till 2007. So let's have a look at it, everyone. This 1 is going to be added in each and every term. This 1 is going to be added in each and every term. So there are 2007 terms. In each and every 2007 terms, 1 will get added. So the addition of those ones is 2007 itself. Then the remaining part of first term is what? 1 by 1 minus 1 by 2. Then the remaining part of second term is what? 1 by 2 minus 1 by 3. The remaining part of third term is 1 by 3 minus 1 by 4, and so on. The remaining part of 2006 term is 1 upon 2006 minus 1 upon 2007, and the remaining part of 2007 term is 1 upon 2007 minus 1 upon 2008. So you can see that all in between terms will get cancelled out. This term, these two terms will get cancelled out. So only first term and last term is remaining. So let's have a look at it. So answer to this question is going to be what? So the addition of all ones is 2007 plus 1 minus 1 upon 2008. So this addition is going to be how much? 2008 minus 1 upon 2008. The answer is option A. This is how we can solve this question number 3. After this, let's have a look at question number 4. Two circles, both of radii 1 centimeter, intersect such that circumference of each one passes through the center of the other. So basically the diagram is going to be like this. Hold on. This is the first circle and this is the second circle, such that these two circles are identical of radius 1 unit each, and they passes through centers of each other. This is the center of first circle, this is the center of second circle. We need to find the area of this common region, intersecting region. So let's have a look at it over here. So let's join these 2 points, another these 2 points, and these 2 points, everyone. These two as well. The radius of these two circles is 1 unit each, means the length of this line segment becomes 1, 1 and 1 each. So basically these two triangles becomes equilateral triangle. All three sides are equal and the measurement of each interior angle will become 60 degree. So over here we need to find the area of common region. So what we can do is, this is the green region. So first of all, let's find the area of this green region. That area is going to be how much? Let's have a look at it. The area of green segment is equal to the area of sector 30 divided by 360 into pi r square minus area of this triangle minus the area of this triangle. Hold on. So the area of this triangle is going to be how much? Root 3 divided by 4 into side square, that is 1 square. So the area of this green region becomes pi divided by 6 minus root 3 by 4. So our final answer is going to be what? Let's have a look at it. The common area is going to be 4 times area of green region. There are 4 such a green portions are there, and area of each of those green portion, this one, then this one, then this one, and then this one is going to be same. So the common area is equal to 4 times green region plus 2 times equilateral triangle, 2 times area of equilateral triangle. There are 2 equilateral triangles are there. So our final answer is going to be 4 times pi by 6 minus root 3 by 4 plus 2 times root 3 by 4 into side square. So let's solve this. This is going to be 2 pi by 3 minus root 3 plus root 3 by 2. So if you solve this further, what you will get? You will get 2 pi by 3. If you take root 3 common, it is 1 by 2 minus 1 is minus 1 by 2, that is minus root 3 by 2. So which option is this? 2 pi divided by 3 minus root 3 by 2. Option E is our final answer here. After this, let's have a look at question number 5. Consider a square ABCD with midpoints EFGH of AB, BC, CD and DA sides respectively. So let's draw a square first of all. This is square A, B, C and D. E is a midpoint of AB, then F is a midpoint of BC, then G and then H. Let L denote the line passing through FH. Let's join F and H like this. Consider 2 points P and Q on this side inside ABCD such that the angle APD and BQC equal to 120 degree. Angle APD is 120, P is point which is inside this square. So that point P is going to be somewhere here. And that point Q, angle BQC is also 120 degree. So over here this is point P, this is point Q, such that this angle becomes 120 degree. So over here this is square, this angle is 90 degree, this angle is also 90 degree. By using symmetry, this 120 degree becomes 60 and 60 over here. This angle is 120 degree. Over here also this angle 120 becomes 60 plus 60 over here. We need to find the ratio of area of ABQCDP to the remaining area inside ABCD. So let's have a look at it. Over here we need to find the ratio of the areas. So you can assume some sides of the square. So let's have a look at it. So over here if I assume this is 36, this is 60, 90, so this angle is going to be 30 degree. So if I assume the length of this side as 1 unit, the length of this side will become 2 and the length of this side will become root 3. By using which concept? Concept of 30, 60, 90 triangles. In 30, 60, 90 triangles, the ratio of sides opposite to 30, 60, 90 is 1 is to root 3 is to 2. Or you can remember side opposite to 30 degrees half of hypotenuse, then side opposite to 60 degrees root 3 by 2 into hypotenuse. If AH is equal to root 3, then HD is also equal to root 3. So basically the side of square becomes how much? Root 3 plus root 3, that is 2 times root 3. So now we need to find the area of which two regions, everyone. Let's have a look at it. The required ratio. Required ratio is area of this green shaded region. This is green shaded region. Area of this green shaded region is how much? Let's have a look at it. For that, what we need to do is area of square. From area of square we need to subtract 4 times area of triangle AHP. For triangle AHP there are going to be 4 such triangles. This is first one, second one, third one and fourth one. This subtraction will represent the area of green region divided by the remaining area inside quadrilateral ABCD, means the remaining area is 4 times area of triangle AHP. This is the remaining area inside quadrilateral ABCD, square ABCD. So let's solve this. The area of square is going to be 2 root 3 bracket square minus 4 times area of triangle AHP is going to be half into basis 1, height is root 3, divided by 4 into half into basis 1, height is root 3. So let's solve this, you will get your answer. So if we solve this further, this is going to be how much? 12 minus 2 root 3 divided by 2 root 3. Now from the numerator take 2 root 3 common, in a bracket 2 root 3 minus 1 is remaining divided by 2 root 3. So over here 2 root 3 and 2 root 3 will get cancelled out, and what we left with is 2 root 3 minus 1 is the ratio of required two areas. So our answer is option E. This is how we can solve this.